General equations include distance equals speed multiplied by time, represented as d equals s times t. Area equals length multiplied by width, represented as A equals L times W. Volume equals length multiplied by width multiplied by height, represented as V equals L times W times H. Percentage equals power divided by whole, multiplied by 100%. Density equals mass divided by volume, represented as ρ equals m divided by v. Algebraic equations encompass several forms. A linear equation is expressed as y equals mx plus b. A quadratic equation is written as x squared plus bx plus c equals 0. A system of linear equations can be exemplified by 2x plus 3y equals 12 and x minus y equals 3. Trigonometry includes sine, cosine, and tangent. Sine of theta equals opposite divided by hypotenuse. Cosine of theta equals adjacent divided by hypotenuse. Tangent of theta equals opposite divided by adjacent. In calculus, the derivative of x to the power of n is n times x to the power of n minus 1. The integral of x to the power of n is x to the power of n plus 1 divided by n plus 1. The limit of x to the power of n as x approaches is a to the power of n. Probability involves the probability of an event, which equals the number of favorable outcomes divided by the total number of outcomes. The distance formula is a fundamental concept. Imagine an object moving at a constant speed. To determine how far it travels, you multiply its speed by the time it's in motion. For example, if a car travels at 60 miles per hour for 2 hours, the distance covered is 60 multiplied by 2, which equals 120 miles. Area calculations are essential for determining the size of two-dimensional surfaces. The area of a rectangle is found by multiplying its length by its width. If a room is 10 feet long and 8 feet wide, its area is 10 times 8, or 80 square feet. For a volume, which measures three-dimensional space, you multiply length, width, and height. Consider a rectangular box that is 5 inches long, 4 inches wide, and 3 inches high. Its volume is 5 times 4 times 3, resulting in 60 cubic inches. Percentages are a way of expressing a part of a whole. To calculate a percentage, you divide the part by the whole and then multiply by 100%. If 30 students out of a class of 100 received an A, the percentage of students with an A is 30 divided by 100 multiplied by 100%, which equals 30%. Density is defined as mass per unit volume. To find the density of an object, you divide its mass by its volume. If an object has a mass of 500 grams and a volume of 250 cubic centimeters, its density is 500 divided by 250, which equals 2 grams per cubic centimeter. Linear equations represented as y equals mx plus b describe straight lines. The term m represents the slope, indicating the steepness of the line, and b is the y-intercept, where the line crosses the y-axis. Quadratic equations, in the form x squared plus bx plus c equals 0, describe parabolas. Solving a quadratic equation involves finding the values of x that satisfy the equation. The quadratic formula is often used to find these solutions. Systems of linear equations involve two or more linear equations with the same variables. Solving such a system means finding the values of the variables that satisfy all equations simultaneously. Methods for solving include substitution, elimination, and graphing. Trigonometry deals with the relationships between the angles and sides of triangles. Sine, cosine, and tangent are fundamental trigonometric functions. Sine of an angle is the ratio of the opposite side to the hypotenuse. Cosine is the ratio of the adjacent side to the hypotenuse. Tangent is the ratio of the opposite side to the adjacent side. These functions are crucial for solving problems involving angles and distances. Calculus introduces concepts like derivatives and integrals. The derivative of a function represents its instantaneous rate of change. For example, the derivative of x squared is 2x, which represents the slope of the tangent line to the curve y equals x squared at any point x. The integral of a function represents the area under its curve. The integral of x is x squared divided by 2, which gives the area under the line y equals x from 0 to any point x. Limits in calculus describe the behavior of a function as it approaches a certain value. For example, the limit of x as x approaches 2 is simply 2. Limits are essential for understanding continuity and asymptotes. Probability deals with the likelihood of events occurring. The probability of an event is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. If you flip a fair coin, the probability of getting heads is 1 divided by 2, because there is one favorable outcome, heads, and 2 possible outcomes, heads or tails. Consider the equation, distance equals speed times time. This is a foundational formula in physics and everyday life. If you're driving a car at a constant speed of 50 miles per hour and you travel for 3 hours, you can calculate the distance you've covered by multiplying 50 miles per hour by 3 hours, which gives you 150 miles. This formula assumes a constant speed. If the speed changes during the journey, you would need to break it down into segments where the speed is constant, or use calculus for a more precise calculation. Next is the area formula, area equals length times width. This is fundamental in geometry and is used extensively in construction, design, and many other fields. For instance, if you're trying to figure out how much carpet you need for a rectangular room that is 12 feet long and 10 feet wide, you would multiply 12 feet by 10 feet to get an area of 120 square feet. You'll need to purchase at least 120 square feet of carpet, plus some extra for cuts and waste. Now let's look at the volume formula. Volume equals length times width times height. This is used to calculate the amount of space occupied by a three-dimensional object, such as a box, a room, or a container. For example, if you have a rectangular storage container that is 5 feet long, 4 feet wide, and 3 feet high, you would multiply 5 feet by 4 feet by 3 feet to get a volume of 60 cubic feet. This tells you how much you can store inside the container. The percentage formula, percentage equals part divided by whole times 100%, is a way to express a proportion or a ratio as a percentage. It's widely used in statistics, finance, and everyday situations. For example, if you score 80 out of 100 on a test, you can calculate your percentage by dividing 80 by 100, which gives you 0.8, and then multiplying by 100% to get 80%. This shows your performance relative to the total possible score. Next is the density formula. Density equals mass divided by volume. Density is a physical property of a substance that describes how much mass is contained within a given volume. It's commonly used in physics, chemistry, and materials science. For example, if you have a rock with a mass of 300 grams and a volume of 100 cubic centimeters, you can calculate its density by dividing 300 grams by 100 cubic centimeters, which gives you a density of 3 grams per cubic centimeter. This tells you how tightly packed the matter is in the rock. The linear equation, y equals mx plus b, represents a straight line on a graph. The slope, m, indicates the steepness of the line, and the y-intercept, b, is the point where the line crosses the y-axis. This equation is used to model linear relationships between two variables. For example, if you're tracking the growth of a plant over time, you might find a linear relationship between the amount of water given and the height of the plant. The slope would represent the increase in height per unit of water, and the y-intercept would represent the initial height of the plant before any water was given. A quadratic equation, x squared plus bx plus c equals 0, describes a parabola, which is a U-shaped curve. This equation is used to model a variety of phenomena, such as the trajectory of a projectile or the shape of a suspension bridge. The solutions to the quadratic equation, which can be found using the quadratic formula, represent the points where the parabola intersects the x-axis. Systems of linear equations involve two or more linear equations with the same variables. Solving these systems means finding the values of the variables that satisfy all equations simultaneously. This is used in various fields such as economics, engineering, and computer science. For example, you might use a system of linear equations to determine the optimal mix of resources to maximize profit in a business. Trigonometry involves the study of triangles and the relationships between their sides and angles. The sine, cosine, and tangent functions are fundamental trigonometric functions that relate the angles of a right triangle to the ratios of its sides. These functions are used in navigation, surveying, and physics. For example, you can use trigonometry to calculate the height of a building by measuring the angle of elevation to the top of the building and the distance from the base of the building. Calculus introduces two fundamental concepts: derivatives and integrals. A derivative measures the instantaneous rate of change of a function. For instance, the derivative of a car's position with respect to time gives its velocity, and the derivative of its velocity with respect to time gives its acceleration. Derivatives are used to optimize functions, find maximum and minimum values, and model dynamic systems. An integral calculates the area under a curve. Integrals are used to find the area of irregular shapes, calculate the work done by a force, and determine the total amount of a substance. Limits in calculus describe the value that a function approaches as the input approaches some value. Limits are crucial for understanding continuity and defining derivatives and integrals. For example, the limit of a function as x approaches infinity can tell you about the function's long-term behavior. Probability is the measure of the likelihood that an event will occur. It's expressed as a number between 0 and 1, where 0 indicates impossibility and 1 indicates certainty. Probability is used in statistics, finance, and gambling. For example, the probability of flipping a fair coin and getting heads is 0.5, or 50%. Understanding these equations and formulas provides a strong foundation for solving problems in mathematics, science, engineering, and everyday life. Make sure to practice applying them in various contexts to solidify your understanding. These formulas are foundational for more advanced studies and practical applications. Understanding these fundamental concepts is crucial for success in many fields. Continuing to practice and apply these formulas will enhance your problem-solving skills and deepen your comprehension.